Hello everyone, welcome to Infinity Learn by Sri Chaitanya. So let's start today's discussion of physics paper, MPL physics paper unit test 5. So let's start with question number 1. The tension in a string holding a solid block below the surface of a liquid where density of the liquid is greater than density of the block as shown in the figure is T when the system is at rest. Then what will be the tension in the string if the system has upward acceleration A? So when the system is at rest, let's draw FBD of the system. So W will be downwards, tension will be downwards, and buoyant force B will be upwards. So if the system is at rest, that means buoyant force is equal to tension plus W. So tension can be written as B minus W. Buoyant force is density of the liquid into volume of the block into G minus weight is density of the block into volume of the block into G. Now, this is the first equation. Now, when the system is moving upwards, what will happen? Its buoyant force will change because the value of G effective will change. It will become G plus A. So, new tension for upward motion, tension is let's say T dash. W will be same. Buoyant force will change. It will become B dash. And acceleration is in upward direction. So in this case, net force B dash minus T dash minus W will be M into A, right? So B dash will be density of liquid into volume into G plus A minus T dash that we want to find minus W is equals to MA. So we can write T dash as rho L V into G plus A minus W, which is density of block into volume into G minus MA. Mass can be written as volume into density. So it will be density of the block volume into A. So you can write this thing as rho L V into G plus A minus rho B V into G plus A. So out of this term, you can take rho L into V common. So it will be rho L into V not common. You can take G plus A common. So it will be, let's take G plus A common. Let me erase this thing. Yeah. So you can take, I'm writing it over here, G plus A common. So this will be rho L into V minus rho B into V, right? But rho L into V minus rho B into V can be written as T upon G using this equation. So it will be G plus A into T upon G is equals to T dash, right? This will be your T dash, and that is equals to G plus A into T upon G. So T into G upon G is 1 plus A upon G is equals to T dash. So new tension in the string will be T times 1 plus A upon G, that is option 2. Question number 2. The kinetic energies of a planet in an elliptical orbit about the sun at position A, B and C are Ka, Kb and Kc respectively. AC is the measure axis and SB is the perpendicular to AC at the position of the sun as shown in the figure. Then we need to compare kinetic energies. So when planet is closer to the sun, it moves faster, right? So it is closest at point A and it is farthest at point C. So its velocity at point A will be more as compared to velocity at point C. So if velocity at point A is greater than at B is greater than at C, then kinetic energy, which is half mv square, will be greater than at A, then B, then at C. So correct answer is option 2. Next is question number 3. The masses each of mass m are kept on the vertices of an equilateral triangle of side A. So this is the situation. We have equilateral triangle of side A. We have 3 masses m, m and m. Find the work done needed to be done to change the length of each side of the triangle to twice of its original value. So if we change the side of the triangle from A to 2A, we need to find the work done in this process. So this is M, M and M, right? So initial potential energy of the configuration is minus G M into M upon A because of this two masses, minus G M square upon A because of this two masses, and because of this two pair we have minus G M square upon A, right? So total initial potential energy is minus 3 G M square upon A, right? Now final potential energy of the system will be, because of this two pair we have minus G M square upon 2A. Similarly, for this two, this and this, we have minus G M square upon 2A, and for this and this we have minus G M square upon 2A, right? So this will be minus 3 G M square upon 2A, right? So we have initial potential energy, we have final potential energy. So work done will be your change in potential energy. So if you calculate the change in potential energy, it will be minus 3 G M square upon 2A minus of minus 3 G M square upon 2A. So it will give you your work done as 3 by 2 G M square upon A. Question number 4. An automobile moves on a road with a speed of 54 km per hour. Radius of the wheel is 0.45 meter and the moment of inertia of the wheel about the axis of rotation is 3 kg meter square. If the vehicle is brought to rest in 15 seconds, the magnitude of the average torque transmitted by its brakes to the wheel is. So torque is given as I into alpha. We need to find alpha first. So alpha, in this case, the magnitude of alpha will be change in omega divided by time. So final omega will be 0 minus initial omega. So V is equals to omega R. So omega will be V upon R. But V is in kilometer per hour. So it is 54 into 5 by 18. So this is 15 meter per second. So it is 15 divided by 0.45. V upon R will be omega divided by time is equal to 15 seconds. So we have alpha as this, and if we take the magnitude of alpha, we can calculate the magnitude of torque required. So tau is I alpha, which is 3 into 15 upon 0.45 into 15, and this will give you torque as 6.66 kg meter square per second square. Question number 5. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 cm. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? So mass of the cylinder is 3 kg and radius is 40 cm and it is a hollow cylinder. That means its moment of inertia about its axis is m r square, which is 3 into 0.4 into 0.4. This is 0.4 meter. Now it is pulled with the force of 40 Newton. So 30 Newton. So it will create a torque. So torque will be F into R, and that is equals to I into alpha. So F is 30, R is 0.4 is equals to I, which is 3 into 0.4 into 0.4 into alpha. So if you solve this one, you'll get the value of alpha as 25 radian per second square, which is equal to option 2. Question number 6. A body is projected up with a velocity equal to 3/4 of its escape velocity from the surface of Earth. The height it reaches is. So let's say this is the surface of the Earth and this is the maximum height achieved by the body. So it is projected with 3/4 of escape velocity from the surface of the Earth. That means it will have kinetic energy as half m into 3 by 4 VE square, which is equals to 9 by 32 mVE square, right? At the same time, it will have a gravitational potential energy minus gmm upon r on the surface of the Earth. When it reaches to maximum height, its velocity will become 0. So only energy that it will have is in the form of potential energy, right? So potential energy at a height h will be minus gmm divided by r plus h. So this is total mechanical energy at height h. This is total mechanical energy on the surface. Now you can apply conservation of mechanical energy. So it is 9 upon 32 mve square minus gmm upon r is equals to minus gmm upon r plus h. Right? VE can be written as VE is escape velocity, which is under root 2 gm upon r. So it is 9 upon 32 into m, 2 gm upon r minus gm m upon r is equal to minus gmm upon r plus h. Okay. So this will become 16. You can cancel gmm from each term. So you'll get 9 upon 16 r minus 1 upon r is equals to minus 1 upon r plus h. If you solve this equation, you'll get 9r minus 16r is equals to 9r minus 16r is equal to minus 16r upon r plus h. Minus 16, sorry, I think I made some mistake over here. Let me erase this equation. Yeah, let's take LCM as 16r. Okay, so this is 16r, so this is 9 minus 16, okay, and that is minus 1 upon r plus h. So this will be minus 7 upon 16r is equals to minus 1 upon r plus h. Cancel minus sign. So we have 7r plus 7h is equals to 16r, and 7h will be 9r. So h will be 9r upon 7, which is option 2. Question number 7. Regarding liquid, the wrong statement among the following is: due to surface tension, it occupies minimum surface area, which is true. This is the property of the surface. Relative motion between the adjacent layers of the liquid opposite by viscous force. Yes, viscous force opposite the relative motion between two adjacent layers of the liquid. Raindrops are spherical in shape due to viscous dragging force. No, raindrops are spherical in shape because of the surface tension property. Okay, because a sphere has the minimum surface area for the given volume, right? So because of the tendency of the surface to occupy minimum surface area, raindrops are spherical in shape. So yes, this is the wrong statement. So correct answer is option 3. Question number 8. A satellite of mass m is moving in a circular orbit with speed v. Then potential energy of Earth satellite system is. So kinetic energy, which is half mv square, and it is plus gmm upon 2r. Fine. Whereas total energy of a satellite is given as minus gmm upon 2r, and potential energy of a satellite moving in an orbit of orbital radius r is minus gmm upon r. Okay. Now you can see that if kinetic energy is gmm upon 2r, then potential energy is minus 2 times gmm upon 2r. If you compare this with this is nothing but minus 2 times kinetic energy, right? So it is minus 2 half mv square, and that is equals to minus mv square. So correct answer is option 1. Question number 9. Two circular rings of equal mass m and radius r are placed touching each other. The moment of inertia of the system about tangential axis in the plane of system passing through point of contact of the ring is. So we have two circular rings like this. This is one ring and this is another ring, and same mass, same radius. Okay. We need to find moment of inertia of the system passing through this about this axis. Okay. So this is r, this is r. Fine. We know what is moment of inertia of this ring about this axis, right? This can be taken as ICM. This axis is passing through center of mass, but it is in the plane of the ring, right? So it is mr square by 2. So using parallel axis theorem, you can find moment of inertia of this ring about this axis, right? About this axis, which is passing through the tangent and touching these two rings. So I can be written as ICM plus MD square. ICM is mr square by 2 plus MD square. D is equals to R. The separation between these two parallel axes is R. So moment of inertia of the one ring about this given axis is 3 by 2 mr square. Similarly, moment of inertia of this ring about this given axis is also 3 by 2 mr square, right? So total moment of inertia of the system will be 3 by 2 mr square plus 3 by 2 mr square, which is equals to 3 mr square. So correct answer is option 1. Question number 10. A ball is released from rest in a very long column viscous liquid. Its downward acceleration is a just after release. Okay. Find its acceleration when it has acquired 2/3 of the maximum velocity. So maximum velocity will be terminal velocity. So when it is just released, its force will be m into a, and it is moving in downward direction with acceleration a. When its velocity will be maximum, that means it's a viscous force 6 pi eta rv will be ma. Net force will be 0 because of the terminal velocity. Terminal velocity is the maximum constant velocity of this spherical ball. Okay. After some time, it is moving with 2 by 3 times terminal velocity. So viscous force Fv in the upward direction will be 6 pi eta r into 2 by 3v. So it is 2 by 3 times 6 pi eta rv. 6 pi eta rv is what? Its total force ma. So it is 2 by 3 times ma. And it is moving in the downward direction. So it is ma and upward force is 2 by 3 ma. So net force over here will be ma minus 2 by 3 ma, and that is equals to ma dash, right? So over here it is 1 by 3 ma, that is equal to ma dash, cancel, so a dash will be a by 3. So its acceleration will be a by 3. Next is question number 11. A hole is made at the bottom of a tank filled with water. So this is tank and this is the hole. So water will come out of this hole with some velocity under root 2gh, where h is the separation of the hole from the free surface of the liquid, like this. Okay. At the bottom, pressure is 3 atmospheric pressure. So at the top, pressure will be 1 atmospheric pressure. Then velocity of efflux is. So we need to find h. So see, at the bottom, total pressure is equal to pressure of atmosphere plus rho gh, pressure of the liquid column. Pressure of atmosphere is 1 atm and pressure of this total is 3 atm. So you can write it as 3 P naught. It is 3 times P naught. P naught is the atmospheric pressure, is equal to P naught plus rho gh. So rho gh will be 2 P naught. So h will be 2 P naught upon rho g. Right. So let's put the value of h in the velocity of efflux formula. So this is 2 g into h is 2 P naught divided by rho g. G cancel, you can take this 2 outside. So this is P naught, which is approximately 10 power 5 divided by rho is 10 power 3 for water. So it will become 20 meter per second. So correct answer is option 1. Question number 12. A disk of radius b and mass m rolls down an inclined plane of vertical height h. So we have this situation in this question. We have an inclined plane of height h, right, and this disk is rolling down. Okay, the translational speed when it reaches the bottom is, what is the velocity? Translational velocity when the disk reaches the bottom of the plane is. So basically what will happen is, when the disk is rolling down, its total kinetic energy will be gained by the loss in potential energy. So loss in potential energy is mgh, which is equals to kinetic energy because of the translational plus kinetic energy because of the rotation. So kinetic energy because of the translational is half mv square, and because of rotation it is half I omega square. Now you can write half mv square as it is, but you'll have to modify this term half I omega square. We have a disk, so its moment of inertia will be mr square by 2. So in this case it is mv square by 2. Omega is v upon r, so omega can be written as v square upon r square for in this case rolling motion. So this will be v square upon b square, right? B square cancel. So we have half mv square plus 1 by 4 mv square, and that is equals to mgh. So it is 3 by 4 mv square, and that is equals to mgh. Cancel. So v square is 4 gh by 3, and v is under root 4 gh by 3. So correct answer is option 1. Question number 13. A force F vector is equals to alpha I cap plus 3j cap plus 6k cap is acting at a point R vector is 2I cap minus 6j cap minus 12k cap. The value of alpha for which angular momentum about the origin is conserved. If angular momentum is conserved, that means torque about that point, that means origin should be 0. So let's find torque, which is R cross F. So this is ijk, positive, negative, positive. R cross F will be 2 minus 6 minus 12, and it is alpha 3, 6. So I cap coefficient will be minus 36 plus 36. So it is already 0. Minus j cap coefficient should be 0, and k cap coefficient should be 0. So it is 12 plus 12 alpha plus k cap, that is 6 plus 6 alpha. So basically tau vector is minus 12j alpha plus 1 plus 6 times 1 plus alpha k cap. So alpha coefficient, j coefficient and k coefficient should be 0. That means alpha plus 1 should be 0, right? So alpha should be minus 1. So correct answer is option 2. Next question is question number 14. The equation of transverse wave is given as y is equals to a cos 2 pi ft minus 2 pi x divided by lambda. The maximum particle velocity is twice of wave velocity if lambda is. So wave velocity lambda is given as lambda into f, right? And maximum particle velocity V max of particle is given as E omega, which is E into 2 pi f. So it is 2 times wave velocity. So this is 2 pi af is equals to 2 lambda f. So you can cancel 2 and f. So lambda will be pi a. So correct answer is option 4. Next is question number 15. A source of frequency 500 Hz emit waves of wavelength 0.2 meter. How long does it take to travel 300 meter? So velocity is lambda into frequency of wave. So it is 0.2 into 500, which is equals to 100 meter per second. So wave is traveling 100 meters in 1 second. So it will travel 300 meter in 3 seconds, right? So correct answer will be option 4. Question 16. The mass of 4 meter wire is 0.01 kilogram and it is pressed by a force of 400 Newton. What is the speed of transverse wave in the wire? So speed is, this is V. Speed of the transverse wave in wire is given as under root T upon mu, where mu is mass per unit length. So it is T, which is 400 divided by mu, that is mass 0.01 divided by 4. So if you solve this one, you'll get speed as 400 meter per second, which is option 1. Question number 17. If the electric field lines of 2 charges are shown, choose correct option. So Q1 and Q2 are 2 charges, and you can see the amount of electric field lines leaving or coming to the charge. So the magnitude of charge is directly proportional to the electric field lines, right? So over here we have 1, 2, 3, 4, 5, 6 electric field lines going away from the charge. So Q1 is like 6x, right? Magnitude of Q1. Look at the Q2. 1, 2, 3, 4, 5, 6, 7, 8. So magnitude of Q2 will be 8x. So Q1 upon Q2 will be 6 upon 8, which is option 3. Next is question number 18. The figure gives the electric potential V as a function of distance through 5 regions on x-axis. Okay. Which of the following is true for the magnitude of electric field E in this region? So E is equals to minus dV by dr. So slope in region 1 and 3, okay, and in 5 it is 0, right? So if slope is 0, dv by dr will be 0. So E1 is equal to E3 is equals to E5 is equals to 0, right? So we have only one possible option for this one, that is option 2, right? And E2 is less than E1 because the slope in region 2 is less than slope in region 4, right? So that is why E2 is less than E4. So correct answer is option 2. Question number 19. The electric field at a distance 3r by 2 from the center of the charged conducting spherical shell of radius r is E. The electric field at a distance r by 2 from the center of the sphere is. So r by 2 from the center is the distance inside the sphere, and we have spherical shell. So electric field inside the spherical shell will be 0. So correct answer will be 4. Question number 20. We have three charges plus q, minus q and plus q placed like this, and we need to find the force experienced by the charge placed at the vertex A in a direction normal to BC. That means we need to find the force in this direction on this charge, right? So if you look at this one, this is your dipole, right? And electric field due to a dipole on any equatorial point is always along the length of the dipole, right? Okay, and in the opposite direction of the dipole moment vector p. Okay, fine. So there's no electric field component present perpendicular to the length of the dipole, perpendicular to the axis of the dipole, right? If E is 0 along this line, then force, which is Q into E, will be 0. I hope this is clear. So correct answer is option 3. Question number 21. An electric dipole is placed at an angle of 30 degree with the electric field intensity 2 into 10 power 5 Newton per coulomb. It experiences a torque equal to 4 Newton into meter. The charge on the dipole, if the dipole length is 2 centimeter, that is 2 into 10 power minus 2 meter. So tau is Pe sine theta. P is Q into D. E is 2 into 10 power 5. Sine 30 degrees 1 by 2, and that is equals to torque 4. So we have torque over here Q as 2 into 10 power minus 3 coulomb, which is 2 millicoulomb. So correct answer is option 4. Question number 22. We have two charges, 12 microcoulomb and minus 6 microcoulomb like this, and the separation is 0.2 meter. Separation is 0.2 meter between these two charges. Okay, like this. There will be a point P on the line joining these two charges and outside the region between them. So let's say this point P is over here on the line joining these two charges, but outside between them, where the electric potential is 0. So electric potential at point P must be 0. The distance of P from the minus 6 microcoulomb charges. So this is, let's say, x. So separation from 12 microcoulomb will be 0.2 plus x. Right, so electric potential due to minus 6 will be minus k into 6 into 10 power minus 6 upon r, which is x, plus because of 12 microcoulomb will be k 12 into 10 power minus 6 upon 0.2 plus x, and that is equals to 0, right? So in this case, if you solve this equation, you'll get the value of x as 0.2 meter, which is option 3. Question number 23. We have three charges placed at the vertices of an equilateral triangle of charge q each. What is the net potential energy if side of the triangle is L? So potential energy due to this and this will be k q square upon L. Due to this and this will be again k q square upon L, and due to this and this will be again k q square upon L. So potential energy will be 3 k q square upon L, which is 3 upon 4 pi epsilon naught q square upon L. So correct answer is option 3. Question number 24. An electron of mass m and charge E is accelerated from rest through potential difference V in vacuum. So potential energy will be Q into potential difference. Change in potential energy will be Q into potential difference, and that will be your converting into kinetic energy. So EV should be half mv square. So velocity V is 2 EV upon m square root. So correct answer is option 3. Question number 25. A metal meter scale has two holes at two ends. When the scale is heated between the two holes, what will happen? Heated, the distance between the two holes will be. So when you are heating this metal scale, thermal expansion will happen. And because of the thermal expansion, length of the scale will increase and the separation between these two holes will increase. So correct answer is option 2. Question number 26. A bimetallic strip is made of aluminum and steel, and alpha of aluminum is greater than alpha of steel. That means on heating, expansion of aluminum will be more as compared to steel. So strip will, what will happen? So as you heat, you provide the same amount of heat to the strip. What will happen? Aluminum will expand more and steel will expand less. And because of unequal expansion, what will happen? This strip will bend. So aluminum is expanding more, so its length will be more, right? So it will be on the convex side and this will be on the concave side, right? So aluminum will be on the convex side, steel will be on the concave side. So it will bend with steel on concave side. So correct answer is 4. Question number 27. For ground to ground projection, range of projectile is 240 meter and angle of projection is 45 degree. Then equation of its trajectory is, so equation in terms of range is y is equals to x tan theta into 1 minus x upon r. So y is equals to x, tan 45 is 1, minus x is x and r is 240. So you can write it as y is equals to x minus x square upon 240. So this is the equation of trajectory, which is option 2. Question number 28. A particle is projected from a point on a ground making an angle of 30 degree with the horizontal. At time t1, 2 seconds, and at time t2, 4 seconds. It is the same height. It is at the same height h above the ground. Then speed of projection is. So this is ground level and this is the path of the projectile. So one time at t is equals to 2 seconds, it will make an angle of 30 degree. Oh, sorry, this is not angle. This is at the same height, right? So let me make this diagram one more time. So this is the path of the projectile. At t is equals to 2 seconds and at t is equals to 4 seconds, it will be at the same height from the ground, right? So it will go 0 to 2 seconds from, it will take 0 to 2 seconds from this point to this point, then 2 to 4, another 2 seconds from this point to this point, and 4 to ground, it will take just 2 seconds because it will, time of ascent is equals to time of descent. So it will take another 2 seconds, right? So total time of flight will be 2 plus 4, t1 plus t2, that is 6 seconds. Fine. And it is equal to 2u sine theta upon g. And that is 6. So u sine theta will be 30. U is 30 upon sine 30 degree, which is 1 by 2, and that is equals to 60 meter per second. So correct answer is option 4. Question number 29. The equation of motion of a particle in SHM is a plus 16 pi square x is equals to 0. In the equation, a is the linear acceleration of the particle at displacement x in meter. The time period of SHM in second is, so you can represent this one as minus 16 pi square into x, right? And you can compare this equation with minus omega square x. So omega square will be 16 pi square. So omega will be 4 pi, which is equal to 2 pi by t, right? So time period over here will be 1 by 2 seconds, which is option 2. Question number 30. The periods of pendulum on two planets are in the ratio 3:4. Acceleration due to gravity on them are in the ratio. So T1 will be 2 pi under root L upon G1 and T2 will be 2 pi under root L upon G2. Right, so let's divide T2 by T1. So it will be 2 pi under root L upon G2 divided by 2 pi under root L upon G1. Right, so 2 pi cancel, L cancel. So we have under root G1 upon G2 is T2 by T1. So G1 upon G2 will be T2 square upon T1 square. T2 upon T1 is 4 by 3. T1 upon T2 is 3 by 4. So T2 upon T1 is 4 by 3. So this is 4 by 3 whole square, which is 16 upon 9. So correct answer is option 4. Question number 31. When an oscillator completed 100 oscillation, its amplitude reduced to 1 by 3 of its initial value. So this is damping ka case. So A can be written as A naught e power minus gamma t. It is completing 100 oscillation and amplitude is 1 by 3 times of its initial value. So in 100 oscillation, time taken will be 100 times time period of one oscillation. So in this case, you can write A naught by 3 is equals to A naught e power minus 100 capital T into gamma, where capital T is the time period in one oscillation. So time period total time in 100 oscillations will be minus 100 T. Right, so I have the value of e power minus 100 T gamma as 1 by 3. Now we need to find its amplitude when it completes 200 oscillations. So its amplitude is, let's say, A dash, that is A naught e power minus gamma 200 oscillations. So this is 200 T. So this is A naught e power minus 100 gamma T whole square. You can write 200 as 100 into 2. So you can write it as e power minus 100 gamma T whole square. But e power minus 100 gamma T is 1 by 3. So this is A naught into 1 by 3 whole square, which is A naught by 9. So new amplitude will be 1 by 9 times the previous one, which is 1 by option 4. Question number 32. The instantaneous displacement of simple pendulum oscillator is given as A sine omega t plus pi by 3. Its displacement will be maximum at time. So its displacement will be maximum when sine is maximum. Sine is maximum when omega t plus pi by 3 is either pi by 2, then 3 pi by 2, then 5 pi by 2, and so on. Right? It is sine is maximum plus 1. Okay, at this angles. So let's take the standard value, that is omega t plus pi by 3 is equals to pi by 2. So omega t is equals to pi by 2 minus pi by 3, that is equals to pi by 6. So t will be pi upon 6 omega, which is option 1. Question number 33. A spring mass system oscillates with a frequency v. If it is taken in an elevator slowly accelerating downwards, its frequency will be. So time period of a spring mass block is 2 pi under root m upon k. So frequency of oscillation will be 1 upon 2 pi under root k upon m. Right. So in this case, you can see that your frequency or time period of oscillation is independent of acceleration due to gravity, and it is independent of the value of acceleration of the lift or the system or frame, right, in which this system is present. So again, if elevator is moving downwards with some acceleration, its frequency will not change. It will remain same. So correct answer is option 3. Question number 34. The period of geostationary artificial satellite of the Earth is 24 hours. It is same as that of the period of Earth, which is option 1. Question number 35. The velocity of a body moving in a straight line is given as 3x square plus x meter per second. Find acceleration at x is equals to 1 meter. So acceleration is given as v dv by dx. So v is just 3x square plus x and dv by dx is 6x plus 1. Now let's put the value of x is equals to 1. So it is 3 into 1. So it is 3 plus 1 into 6 plus 1. So this is 4 into 7, that is 28 meter per second square, which is option 3. Question number 36. The average velocity during a journey of 240 meter with uniform acceleration 5 meter per second square is 40 meter per second. The initial velocity of the body is. So basically u plus v by 2, which is equals to s upon t, is equals to 40, right? So u plus v is equals to 80 and s upon t, that I don't know, is equals to 40, but s is given as 240. So you can find the time. So in this case, 240 divided by 40 will be time. So time is 6 seconds. Now I know what is acceleration. It is v minus u upon time. So v minus u upon 6 is equals to acceleration, which is 5. So v minus u will be 30 and we have v plus u will be 80, right? So let's subtract this equation. So this will cancel. We have minus 2u is equals to minus 50. So u will be 25 meter per second. So this is the value of initial velocity. Question number 37. A stationary man observes that the rain is falling vertically downwards. Okay. So this is the velocity of rain when the man is not moving. When he starts running with a velocity of 12 km per hour, he observes that rain is falling at an angle of 60 degree with the vertical. So this is velocity of rain with respect to man. The actual velocity of the rain is. So in this right angle triangle, you can see that tan 60 degree will be 12 upon VR. So velocity of rain will be 12 upon tan 60 degree, which is root 3. So it is 4 root 3 km per hour, which is option 4. Question number 38. A body is projected vertically upwards with a velocity of 30 meter per second. It crosses a horizontal line AB at a height h above the ground, first during its upward journey and another time during its downward journey in a time interval of 5 seconds. That means it will take 2.5 seconds for upward and 2.5 seconds for downward for AB level. Then height h of the line AB is equal to. So it is projected with 30 meter per second. So its velocity will become 0 in time, u upon g, that is 30 upon 10, that is 3 seconds. So it will take 3 seconds to go up at its maximum height. But out of this 3 seconds, it is taking 2.5 seconds from AB to maximum height, right? So only 0.5 second will be taken to cover this height h, right? So let's write equation up to height h only, that s is equals to ut plus half et square. So s is h, u is 30, time is 1 by 2 plus half, e is 10 minus 10, sorry, into t square is 1 by 2 whole square. So if you solve this one, you'll get the value of h is 13.75 meter, right? Question number 39. A bomber flying horizontally with constant speed releases a bomb from an airplane. So bomber is flying with velocity u. When it releases a bomb, it will gain the velocity of the bomber, which is u only. Since there is no relative velocity, relative velocity of the bomb with respect to bomber, of relative velocity of bomber with respect to bomb is equals to 0, right? So path of the bomb as seen by the bomber will be a straight line. Okay, fine. Path of the bomb as seen by the pilot is a straight line. Okay, or it is same with respect to the airplane also, because pilot is in the airplane. So path of the airplane with respect to the bomb is also a straight line. Okay, but if someone observing this thing from the ground, it will be like this, horizontal projectile. Why? Because u is the horizontal velocity and acceleration due to gravity is in vertically downward direction. So this will follow a parabolic path. Okay, so path of the bomb as seen by the observer on the ground will be a parabola. So we have 3 statements correct, 1, 2 and 3. So correct answer is option 3. Question number 40. A body is thrown with velocity 4i cap plus 3j cap meter per second. Its maximum height is. So maximum height is given as uy square divided by 2g, which is 3 into 3 divided by 2 into 10. So it will be 0.45 meter. Question number 41. A stone is projected from the top of a tower with velocity 20 meter per second, making an angle of 30 degree with the horizontal. If the total time of flight is 5 seconds, g is 10 meter per second square, then height of the tower is. So it will perform this motion like this. It will fall to the ground. This is ground and this is height of the tower edge. So let's take components. So this component will be 20 cos 30 degree and this component will be 20 sin 30 degree. So let's write this equation. Sy is equals to uyt plus half ay t square. Sy is h minus h because it is in the opposite direction of initial velocity. Uy will be 20 sin 30 degree, which is equal to 20 into 1 by 2. Time is 5 plus half ay will be minus g into t square is 5 ka square. So this will give you the value of height as 75 meter. Question number 42. A projectile is thrown at an angle 30 degree with a velocity of 10 meter per second. The change in velocity during the time interval in which it reaches the highest point is. So this is the point of projection. 10 meter per second, 30 degree angle. So this component is 10 cos 30 degree, which is equals to 10 root 3 by 2, which is 5 root 3. And this component is 10 sin 30 degree, which is 5 meter per second. And at highest point, it will have only horizontal component, which is 5 root 3. So you can see that only change is happening along vertical direction. There is no change in horizontal direction. So change in velocity will be 5 meter per second only, which is option 2. Question number 43. A body falls freely from the top of a tower. It covers 36% of the total height in the last second before striking the ground level. The height of the tower is. So this is h and let's say it is covering in t time. And it covers 64% of the total height in t minus 1 time, because in last 1 second it is covering 36% of the total height. So remaining height, that is 64% of the total height, which is 0.64 h, is covered in t minus 1 second. So we can write equation h is equals to half gt square for the complete journey, and for 0.64 h we can write it as half g t minus 1 whole square. So this is equation 1, this is equation 2. Now let's divide this two equations. So you'll get this one. So we have 1 upon 0.64 is equals to t upon t minus 1 whole square. Take the square root. So this 1 upon 0.8 is equals to t upon t minus 1, or t minus 1 is 0.8t, which is equal to 0.2t is equals to 1, and t is 5 seconds. Now let's put the value of t in first equation. So it is half 10 into 5 into 5. So total height will be 125 meter, which is option 4. Question number 44. A ball is thrown vertically downwards with a velocity of 20 meter per second from the top of a tower. It hits the ground after some time with a velocity of 80 meter per second. The height of the tower is. So you can apply this equation. V square is equals to u square plus 2gh. V square is 80 square is equals to 20 square plus 2 into 10 into h. So it will give you the value of h as 300 meter, which is option 3. Question number 45. A uniform metal rod is used as a bar pendulum. If the room temperature rises by 10 degrees Celsius and the coefficient of linear expansion of the metal rod is 2 into 10 power minus 6 degree per degree Celsius, the period of the pendulum will have percentage increase in. So percentage increase in the period of the pendulum is given by half alpha delta t into 100. So this will be half alpha is 2 into 10 power minus 6 into delta t is 10 into 100. So this will be 10 power minus 3%, which is option 4. 46th question. Two rods of the length L1 and L2 are made of materials whose coefficients of linear expansions are alpha 1 and alpha 2. If the difference between two lengths is independent of temperature, then which of the following relation is correct? That means the increase in length, the delta L1 should be equal to delta L2. What is delta L1? It is L1 alpha 1 delta T, and it should be equal to L2 alpha 2 delta T. Delta T cancel. So we have L1 alpha 1 is equals to L2 alpha 2, or you can write L1 upon L2 is equals to alpha 2 upon alpha 1, which is option 2. Question number 47. We have thin brass sheet of at 10 degrees Celsius and thin steel sheet at 20 degrees Celsius. Have the same surface area. Okay, initial surface area A0 is same. The common temperature at which both would have the same area is. So again, after some time, after some change in temperatures, we want the surface area to be same. That means expansion in the areas delta A1 should be equal to delta A2, right? So delta A1 for the first one, brass sheet will be A0 alpha of brass, that is 19 into 10 power minus 6. So this is alpha, so we need to write beta. So this is 2 alpha, beta is 2 alpha, so it will be 2 times alpha of brass into delta T. So change in temperature for the brass is T minus 10, right? And this should be equal to delta A2, that is increase in area of the steel, that is A0 into delta A. I'm writing this equation. Delta A is equals to A0 beta delta T. So A0 beta is 2 alpha. So this is 2 alpha of steel is 11 into 10 power minus 6 into T minus 20, right? So I'm just assuming that the common temperature is T. So if you solve this one, you'll get the value of temperature as T as minus 3.75 degrees Celsius, which is option 1. Question number 48. A particle moves towards east with velocity 5 meter per second. So initial velocity vector is phi I cap, and after 10 seconds, its direction changes towards north with same velocity. So final velocity vector is phi j cap. Average acceleration is, so average acceleration vector will be v final vector minus v initial vector, which is phi j cap minus phi I cap, divided by time also. So this is 10, right? So we have 1 by 2 j cap minus 1 by 2 I cap, right? So this is the vector format. Let's find magnitude also. So acceleration magnitude will be under root of 1 by 2 square plus minus 1 by 2 square, which is equals to 1 by root 2 meter per second square. Fine. And our direction will be, you can see that this is 1 by 2 j cap. So it is like this, and 1 by 2 j cap is over here and minus 1 by 2 I cap is over here. So using parallelogram law of vector addition, you can find its direction. So these are 1 by 2 and 1 by 2 magnitude. So equal 45 degree will be there with resultant. And this is your northwest direction. So correct answer is option 2. Question number 49. Radius of a sphere is 100 centimeter at 0 degrees Celsius and 100.1 centimeter at 100 degrees Celsius. What is the coefficient of cubical expansion? So we know that delta R will be R naught alpha delta T. So delta R is 0.1 centimeter is equals to R naught, which is 100 centimeter into alpha into delta T is 100. 0 to 100 degrees Celsius is the change in temperature, right? So alpha will be centimeter cancel. So it is 10 power minus 5 degrees Celsius inverse. But we need to find gamma, which is equals to 3 alpha. So this is 3 into 10 power minus 5 degrees Celsius inverse, or 30 into 10 power minus 6 degrees Celsius inverse, which is option 1. Question number 50. The coefficient of cubical expansion of a solid is this one in degrees Celsius inverse. So gamma in degrees Celsius is given as 0.000027 degrees Celsius inverse, or you can write it as 2.7 into 10 power minus 5 degrees Celsius inverse. Okay. Now, if the temperature is measured on Fahrenheit scale, what is the coefficient of linear expansion? right? So we need to find alpha in degree Fahrenheit scale, not in degree Celsius scale. So gamma on degree Celsius scale is equals to 9 by 5 times gamma in degree Fahrenheit scale. Okay? So gamma in degree Fahrenheit will be 5 by 9 into 2.7 into 10 power minus 6, right, which is gamma degree Celsius. So this will be, let's remove one more zero. So this is 3. So we have 1.5 into, this is 10 power minus 5 degree Fahrenheit inverse. Okay, so we have gamma as 1.5 into 10 power minus 5 degree Fahrenheit inverse, right? But we need to find alpha. So alpha will be gamma upon 3, which is 1.5 into 10 power minus 5 divided by 3. So it will be 0.00005 degree Fahrenheit inverse, which is option 2. So that is it for today's session, guys. Thank you so much for watching. I'll see you again in the next session. Take care, everyone. Bye bye.